In this course, I want students to exercise critical thinking skills when reading procedures. In order to use those critical thinking skills, students must first have a solid understanding of techniques. To provide an example of the exercise that I expect students to work through, let's have a look at the following procedure to synthesize ethyl 1,2,3,4-tetrahydro 6-methyl-2-oxo-4-phenylpyrimidine 5-carboxylate. Put the video on pause and have a read through the procedure before proceeding. The questions I'll ask myself are 1. Can I identify the synthesis, workup quench, purification, and analysis steps? 2. Which is the limiting reagent? 3. Why is it used as the limiting reagent? 4. During the workup quench step, why is water used? Can it be substituted with another solvent? 5. Why would rinsing with 95% ethanol remove product stickiness? And 6. What product analyses were conducted, and how do they indicate product identity and purity? Here are the steps of synthesis, quench workup, purification, and product analysis. If we look back at the reaction equation, notice that the reaction occurs in a 1:1:1 mole ratio. Therefore, there are two limiting reagents, benzaldehyde and ethyl acetoacetate. Having the urea in excess would be enough to drive the reaction forward, so it would be pointless to waste either benzaldehyde or ethyl acetoacetate as well. The question of why benzaldehyde and ethyl acetoacetate are used as limiting reagent can also be rephrased as why is urea used in excess. There are two answers to this. One is that urea is inexpensive, and the other one relates to the workup step of adding water. Urea is water soluble and therefore can be removed easily, while benzaldehyde, ethyl acetoacetate, and the product are not water soluble. Can the water in the workup step be substituted with another solvent? Its purpose is to remove the Lewis acid catalyst and the excess urea. So another solvent could be used provided that it dissolves both of these compounds, but not the product. Product stickiness is the result of strong hydrogen bonding to residual water. By adding ethanol, this solvent dissolves and removes the water, so therefore minimize the hydrogen bonding partners. The product was only analyzed by melting point and IR spectroscopy. For melting point, we are looking for a sharp melting point to compare the literature value for product conformation. If the value is broad and depressed from the expected value, then we know that the product is contaminated. With the IR spectrum, we can look for functional groups that match the product, but also for the presence of functional groups that don't. For example, if the aldehyde CH was present in the IR spectrum, then we would know that there's likely a contaminant. To conclude this video, I ask that students ask themselves these sorts of questions and come up with reasonable answers. There's a purpose to doing every step in the procedure, and make it a goal to understand why. Students should feel free to see me if they have any questions about the procedures.